Uh, so hey guys, so this is day 6 of solving programming problems, and today we're gonna solve one of the easy problems in Gigs for Gigs, which is to find the leaders in an array. So what exactly are leaders in an array, right? I'm gonna go through an example to show you what leaders in an array are, and then show you the algorithm to solve the problem, and then show you the code in Java to actually solve this problem, right? So let us take an example array here. So leaders are in an array are elements in an array where the right elements that are on the right hand side of the array are lesser than the element itself. For example, if you take 5, every element that's on the right of 5 is lesser than 5 itself. And if you take 17, for example, every element that's on the right side of 17 is essentially lesser than 17. So 17 is again a leader in the array. So the goal of the problem is to find all the leaders of the array and then return it as an array list. And to solve this problem, we're going to use a pretty straightforward method, which is to have a variable called maximum so far initialized, and then iterate the array backward from the back of the array. So we're going to start from 2, and then we're going to iterate it all the way through 16. So we're just going to do one iteration, and we're going to find all the leaders in the array. So to start with, what we would do is that we would compare the last element, which is because we are iterating from I last position, right? So we would compare the last position and the maximum so far, and if maximum so far is lesser than the element at position I, we would add the element at position I to the final result array that we have. I'm just gonna have a result array here, and then we're gonna set the maximum so far to the value of oops to the value of the last element. And once we do that, we're gonna decrement the value of I to here, and then gonna compare the element at position I with the maximum so far. And if maximum so far is lesser than the element at the index I, we're gonna add the element at index I to the final resultant array here. And then we're going to decrement the value of I to here, and then we're going to before we do that, we're going to set the value of maximum so far to 5, so it would get updated to 5 here. And then we're going to decrement the value of I, which comes from 5 to 3 here. And then we're going to compare the element at position 3 with 5. So since the maximum so far is actually greater than the element at position I, we're not going to add this, and we're not going to update maximum so far. We're just going to decrement the value of I to here. And the same happens here because maximum so far is greater than the element at position I. So we're not going to do any changes to maximum so far. We're going to add any elements to the resultant array, and then we're going to decrement the value of I to here. Now maximum so far is lesser than the element at index I, so it's lesser than 17. So what we're going to do is that we're going to update maximum so far to be 17, and then we're going to add the index element of index I to the resultant array. And after we do both of these things, we're going to decrement the value of I by 1, and then I will be 16. So 16 is lesser than maximum so far, so we're not going to add anything to the array. We're just going to decrement the value of I, and since it goes beyond the limits of the array, we're going to end the loop, and these three elements are essentially the leaders of the array. So this is the algorithm that we're going to use to solve the problem, and I'm going to code this in Java right now. So back to the problem here, we're given an array, which is the array that we're going to use, and we got the number of elements in the array. The first thing to do here is to declare maximum so far. I'm going to set it to 0, and we're going to do an iteration from I equal to n minus 1, and then I is less than or equal to 0, and then I minus 9. So we're decrementing from the last element. So while we do that, we're going to check if maximum so far is indeed less than or equal to the array of index I. And if it is less than the array of index I, or we want to return the response, right? So we're going to declare the response variable here. I'm going to declare an array list of type integer. Uh, I'm going to name it as result and then initialize it, array list. Yep, done. So I'm going to add the element of index I since it is greater than the value of maximum so far. So result dot add array of index I, and then I'm gonna update the value of maximum so far to the element at index I, right? So I'm gonna do that, and then it's automatically gonna I decrement the value of I because of the iteration that we do. And after we do all of this, since we are like uh, iterating the array from the back, what happens is that our the resultant array that we get is in the reverse order than it would have been if we have went in this direct order from first to last. So if you take a look at here, it's 2 5 17, but the example shows it as 17 5 2. It's in reverse because we did the whole iteration in reverse. So at the end of this array, I'm just going to use collections dot reverse to reverse the array list before I return the result. So do that, then I'm going to compile it. Hopefully I don't get any compiler issues. Yep, we got the right. Okay, we didn't add anything. Oops, sorry. So it was supposed to be greater than, but I don't know why. Like I missed that out. See now. Yep, we got the result. I'm gonna submit this. So there you go, guys. This is pretty straightforward. We are iterating from back. We are checking with the maximum so far variable to add results to an array, and then we're reversing the whole thing, and then we're returning back the results. So that is the problem for the day. See you guys tomorrow for the next problem.